Today's class, let us see what is the syntax of fgets. Now here fgets is a function. The first argument for the function fgets is str, where str is an array of characters. So before using the function fgets, we have to declare the variable str as str of 15. It is an array of say 15 characters. Whatever characters we read from the file, that will be copied into this str. So str is an array of characters. The sequence of characters read from the keyboard or from the file are stored in the variable str. So this is the first argument. The second argument is n. Here n represent the number of characters to be read from the file. So because it represents the number of characters, we have to declare n also. So n can be declared as integer. So after reading n minus 1 characters, even though we specify n here, we are supposed to read maximum of n minus 1 characters into the string str. So after reading n minus 1 characters from str, a null character /0 is attached at the end. If n is equal to 6, we read 5 characters, and after reading 5 characters, that 5 characters will be terminated with the /0. So the second argument is n. The third argument and another point is, while reading n minus 1 characters from the file, suppose we encounter /n. Still we have not encountered n minus 1 characters, but during that process, suppose we encounter /n. /n character is also copied into str, but immediately after /n is copied, a null character /0 is appended. N may be 10. Immediately after 5 characters only, we may encounter /n. So 5 characters followed by /n followed by /0 will be there in str. Is appended, /0 is appended at the end. Now fp, third argument is fp. Fp is a pointer. Fp is a pointer to a file from where the data has to be read. So we have to declare fp. Fp is a pointer to a file, and this file, the definition is available in stdio.h. So here you have to include stdio.h. So if fp is pointing to stdin, what is stdin stands for? Standard input. What is standard input? Normally it is a keyboard. So if fp is pointing to a standard input, that is keyboard, the data is read from the keyboard. If fp is pointing to a source file, then the data is read from the source file. So the function fgets accepts how many arguments? 3 arguments, and the function fgets returns a pointer to a string str. So here that pointer I am going to copy into ps. So here we say ps is a pointer to a string. So here we have to declare ps is a pointer to a string or pointer to a character. So if a string has not been read successfully, ps points to null. If the data has not been read successfully from the keyboard, ps points to null. Otherwise, ps points to the string which is available in the variable str. Now the function fgets returns a pointer to a string if string is read successfully. Null if the string has not been read successfully. And we know that the definition of file is available in stdio.h. So go here and write #include stdio.h. So we know how to use the function fgets. It accepts how many arguments? 3 arguments. First one is string, number of characters, and the file pointer. Now let us see, using this function fgets, we think of how to read the contents from the file. Okay, next thing is let us read a line from the keyboard and display it. So let us do this using the function fgets. Now here we enter the data from the keyboard, and whatever data we enter, that will be copied into a buffer called keyboard buffer. Whatever we enter from the keyboard, it will be stored in this buffer, and this buffer we call it as keyboard buffer. At the same time, whatever we type from the keyboard, that will be displayed onto the screen also. Okay, now let me try to read a line from the keyboard using which function? fgets. can you think of what is the syntax? I already showed in the previous slide what is syntax of fgets. First we have str. Now followed by n. What n represent here? 10. It means maximum of 10 characters, that is including /0 we have to specify here. 10 represent maximum number of characters that are available in str including /0. So I say str 10 comma std in. File pointer it is now here std in. Std in means the file pointer points to the keyboard buffer. So let us declare str is an array of characters, and then the moment I declare like this, memory will be allocated for str. 10 bytes of memory locations will be allocated for str. Suppose I use the statement printf enter the string. Can you tell me what will happen? This message will be displayed on the screen, enter the string. This is during execution. Now when this statement is executed, we are supposed to enter the data from the keyboard. Suppose we enter ABC. Whatever we enter, that will be displayed onto the screen also. Then we may type space DEF, that also will be displayed onto the screen. Now if I press enter, and using the function fgets, if you observe, the data is read from standard input. How many? Totally 10 characters. Here how many characters I have pressed? 1, 2, 3, space is 4, 5, 6, 7, and here I press enter key. So when the moment I press enter key, that is nothing but /n here, and that will be copied into string str. So ABC space is 4 DEF 1, 2, 3, 4, 5, 6, 7, and this is 8. Totally how many characters have been copied? 8 characters have been copied into str. Now after that a null character will be appended at the end. So here we write /0. So this is how we can read the data from the keyboard using fgets. It's not that we have to use the scanf only, we can use fgets also. And whatever the function fgets returns, that will be copied into the variable ps. So here ps is a pointer. So ps points to the string because ps, the reading is successful. We have successfully read from the keyboard and the data is available in str, and the returned value will be copied into where now? PS. That is starting address of the first byte will be returned, and that will be copied into PS. So we should declare PS as a pointer to character. Next, now suppose the data has not been read successfully from the keyboard. In that case, PS will not point to the beginning of the string. Instead, PS points to null. PS contains null. So here we check whether PS is equal to null or not. If PS not equal to null, what is the meaning? The string has been read successfully, and this which is available in str, that has to be displayed. So here I write the string is. So here the message, the string is displayed on the screen, and then we say put as str. What is there in str? Instead of using printf to print the value of str, we use putS. So the moment I say putS, whatever characters are available in str till you encounter /0, all those characters will be sent to the output device. So the output will be ABC space DEF, and because of this /n here, cursor comes to the next line. Next, we terminate the program. Let us return the control to the operating system. Now if PS not equal to null, tell me how many statements you are executing? 3 statements. Whenever you have more than one statement here, all those statements must be enclosed within braces. So I hope you understood. Now here all these statements, we enclose them within the braces. Here I write void main, and normally before this we include stdio.h. So here I write hash include stdio.h. So this is the complete program to read a line from the keyboard and display it onto the screen. Now let me execute this program once again. If this is the statement to be executed, tell me what is the output we get? This message enter the string will be displayed on the screen. When control comes here, when this statement is executed, we are supposed to enter maximum of how many characters from the keyboard? 10 characters. Suppose I type Ctrl Z. If I type Ctrl Z, can you tell me what will happen? That is Ctrl Z stands for end of file here. In that case, PS contains null. So the null f gets will return what? Null, and that null will be copied into which variable? PS. Now PS contains null. Now control comes here. Is PS not equal to null? It is equal to null. What will happen? All these statements are skipped. Control simply comes out of this statement and the program will be terminated. Now we know how to read a line from the keyboard. So immediately once the control comes out, we can display the message reading is unsuccessful. So this message will be displayed on the screen, reading is unsuccessful, because we have simply set control Z. Okay. Now let us execute the program once again. Execution always start from the function main. Now the moment control comes here, 15 bytes of memory will be allocated for the variable str. So PS is a pointer, so 2 bytes will be allocated for the variable PS. Now PS is a pointer, it should contain the valid address. Now tell me, will it contain valid address? No. In that case we say PS is a dangling pointer. Now when control comes here, we get the message enter the string on the screen. So here I get the message enter the string. Next, this statement is executed. Now suppose I type A, B, C, D, E, F, G, H, I, J. Tell me how many characters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 characters are there. So here what? 10 characters. But remember, we can enter maximum of 9 characters, but we have entered how many characters here? 10 characters. Let us see what will happen. Whatever characters we enter from the keyboard, those characters will be displayed as it is on the screen. Okay, and this A, B, C, D, E, F, G, H will be copied into str, but remember we are supposed to copy maximum, not 10. We are supposed to copy only 9 characters. So only 9 characters of this, that is A, B, C. If you count 1, 2, 3, 4, 5, 6, 7, 8, all 9 characters have been copied. J has not been copied. Only A, B, C, D, F, G, H, I will be removed from the keyboard buffer, and that will be copied to str. This J and /n will be still available in the keyboard buffer only. Now these 9 characters will be terminated with a null character. Now the reading is successful. Now the function f gets should return first byte, address of the first byte of str, and that should be copied into which variable? PS. So here the address of the first byte will be copied into PS. So this arrow mark shows this PS is pointing to string str. Now when control comes here, tell me, is PS null or it is not null? Because PS contains the valid address, so definitely PS is not null. So control comes here and this statement is executed. So we get the message the string is on the screen. And when this statement is executed, put as str. What is that in str? A, B, C, D, E, F, G, H, I. That will be displayed on the screen. Then finally, when this statement is executed, control is returned back to the operating system. So that's how we can read a line from the keyboard and display it onto the screen. Okay, now let us see how to read a line from the file. Earlier in the program, here if you observe, we are reading the data from the file, from the keyboard, because file pointer is stdin, it means it is pointing to the keyboard. Now we don't want to read from the keyboard, instead we have to read a line from the file. So what we should do? Change this to FP. Now what should be FP? FP is a pointer to a file. Which file? I want to open this particular file in read mode. So this file will be available in the hard disk, and suppose we have ABC space DEF and /n, and this is the contents of the input dot dot. So we have to open this file in which mode? Read mode. So here we have to write the mode, within double quote we write R. So we call the function fopen with these two arguments. First argument being the file name, the second argument being the mode in which that file has to be opened. So in read mode we have to open. So the fopen functions, the fopen returns a pointer to the beginning of this. So FP is now points to this. Now if the function has not been opened successfully, in that particular case fopen returns null, and that null will be available in the variable FP. So here we check whether FP equal to null. If FP equal to null, what is the meaning? There is error in opening the file, and immediately we terminate the program. So these two statements must be executed whenever this condition is true. So what should I do? I enclose these two statements within the braces like this. Okay. Now fp is a pointer to a file, and then we have declared str, which is an array of characters, and then we define ps. Ps is pointer to character. Now enclose all these statements within the braces, and here we write void main, and here we write hash include stdlib.h. Because of exit 0, we include stdio.h because the declaration of the printf is available in stdio.h. So this is how we can write a complete program to read a line from the file and display it onto the screen. Now execution start from the function main. The moment control comes here, memory will be allocated for the variable fp. fp is a pointer. Now still you have not stored anything, so fps is dangling pointer. When control comes here, memory will be allocated for str, and by looking at this statement, memory will be allocated for ps. Now here the first statement which is being executed is fopen. We open this file in which mode? Read mode, and definitely the function fopen opens the file successfully, and the function fopen returns a pointer to a file, and the pointer to the beginning of this file is copied to which variable? Fp. So the pointer to the beginning of this file input.dat will be returned by the function fopen, and that will be copied to which variable? Fp. So fp points to the beginning of the file. When control comes here, we check whether fp is equal to null. Now tell me, is fp equal to null? No. So control simply comes out, and these two statements will not be executed, they will be skipped. So control comes here, and we try to read how many characters from the keyboard? Maximum of 10. 1, 2, 3, 4, 5, 6, 7, 8 characters are there, and those 8 characters will be copied from the file into which variable? Str. So it will be copied into str, and a null character will be appended at the end. So we have executed this. Now the function fgets returns pointer to str, and that pointer to str will be copied where now? ps. So pointer to this will be copied into the variable ps. So we say ps is a pointer. Now when this statement is executed, is ps not equal to null? Yes, definitely ps is not equal to null, because it is pointing to the beginning of the string. So control enters into the if statement. So we get the message this statement is executed, that is we get the message the string is. And when this statement is executed, we say put as str. What is there in str? A, B, C, D, D, E, F, followed by what? Slash n. That slash n means cursor comes here, and the cursor will be blinking at this particular point. Now when this statement is executed, program will be terminated. I hope using fgets we have seen how to read a line from the keyboard, or how to read a line from the file and display it onto the screen. Now let us see another function just opposite of fgets is fputs. Fgets is used to read the data from the keyboard, from the file, whereas fputs is used to write the data into the file. The syntax is similar to the previous one. Fputs followed by what? Str followed by the file pointer. So what is this str? Str is an array of characters. So here I write str of 15 is an array of characters. The sequence of characters to be sent to the output stream are stored in the variable str. Then the second argument is fp. So here we say fp is a pointer to a file where the data has to be written. So let us declare fp as a pointer to file. Okay, now the declaration of the file is actually a type defined structure which is declared in stdio.h. So go here and write hash include stdio.h. So this is the syntax of fputs. If fp is pointing to standard output, which is a standard output, the monitor is a standard output device. So if fp is pointing to std out, then the data is displayed on the screen. But if fp is pointing to a destination file, then the data is written into the destination file. Now the function f puts, it returns a value, and that value will be copied into which variable? ch. So here ch is if write operation is successful, the function f puts returns the last character written into the file, and it is copied into variable ch. So which is the last character written into this particular file, and that character will be copied into which variable here? ch variable. And finally the function returns eof if there is any error while opening the file in write mode. The return type is integer. So that is the reason we say ch is of type integer, because eof is returned. eof is defined as -1 in stdio.h. So we have to declare ch as an integer. I hope you understood what is the syntax of f puts. Okay, now let us see how to read the data from multiple lines and display it onto the screen. Now we read the data from the keyboard. Whatever we enter, that will be copied into the keyboard buffer, and whatever you type from the keyboard, that will be displayed onto the screen. Let us use the function fgetS. fgetS str followed by what here? Str. What is str? It is an array of characters, and here the moment I write the statement here, during execution memory will be allocated, and the memory, how many memory bytes will be allocated? 15 bytes of memory will be allocated for the variable str. And here we try to read maximum of 10 characters into this str. So from where? From stdin. Okay, now what it returns? It returns the pointer to a string, the pointer to a character. So that will be copied into which variable? ps. So ps is a pointer to a character. So here we write ps is pointer to a character. The moment I write the statement, by looking at this, compiler will allocate how many bytes? 2 bytes of memory for the variable ps. Now let us see what will happen. So first, if I say printf, enter the few lines that will be displayed on the screen. By looking at this statement, if you type abc, abc will be displayed. If you type def, def will be displayed. If you type /n, okay, the string which is there in the keyboard buffer, it will be copied into which variable? str. So it means read how many characters? 10 characters from where? From the standard input device. That is nothing but keyboard buffer. So read this data and copy into which variable? str here. So the data is read from the keyboard, and that will be copied into str, and the function fgets returns a value, returns a pointer to the beginning of this into which variable? ps. So here we write a pointer here. Next, while ps is not equal to null. Is ps null? No, because ps not null, because it is pointing to this. Let us enter into the loop. Here we say f puts str comma std out. If you see f puts str comma std out, what does std out stands for? Standard output. So str is sent to the standard output, means a, b, c, d, f should be displayed onto the screen. So after f puts, let us try to read another string. So I say fgetS str comma 10 comma std in. Again we read the 10 characters from the standard input device, we copy into str, and that will be the function fgets returns a value that will be copied into where now? ps. Now see what's happening here. Is ps not equal to null? Yeah, definitely ps is not equal to null. If ps not equal to null, these two statements are executed. Now all these statements are enclosed within the braces. Here I write void main, and here I write hash include stdio.h. Okay, now let me execute this particular part. Is ps not equal to null? Definitely ps is not equal to null. So control enters inside the loop, puts f puts str comma std out. So abc df will be sent to the output device. abc df will be sent to the output device. See what I am doing here. Again we are trying to read a set of characters from the keyboard. Okay, suppose I type 1 2 3 4 5 6 7 8 9, and that will be displayed onto the screen, and that will be copied into which variable? str. So we can read from the keyboard, and that will be copied to where now? str. So 1, 2, 3, 4, 5, 6, 7, 8, 9 will be copied, and it ends with what? Null character. Again control goes back, still PS is not equal to null, it is pointing to something. So control enters here, and F put as str, std out means what is here? 1, 2, 3, 4, 5, 6, 7, 8, 9. That will be displayed as it is on the screen. So after this, again control goes back here, and we check whether PS is not equal to null. Now suppose I type nothing from the keyboard. In that case, what will happen here? PS will be null. When PS is equal to null, again control goes back. Yes, PS not equal to null, it is equal to null. Control simply comes out, and the program will be terminated. Now using this, we can read multiple lines from the keyboard, and we can display it onto the screen. Now how to read multiple lines and display onto the screen? So this is how we can do that. Now I'll slightly change. Here I remove this not equal to null here. Okay, even the if I execute this program, the output is same as the previous one only. Now let us concentrate on a program wherein I have to read from a file and have to write into 3 different files. Suppose there is one file by name input.dat. The data stored in input.dat is something like this: A apple, A Amar, B Baba, B banana, C cat, and C camel. Here anything which is starting from lowercase letter a, let us write that into one file. Anything that starts with a lowercase letter b, let us write into another file. And anything that starts with C, so we write into another file. So total how many files we have to create? 3 different files you have to create, but only one file exists. Now let us say what to do. We have to open this particular file. In which mode? Read mode. So what should I write here? Within the double quote R. So if I have to open this file in read mode, which function I have to call? fopen function I have to call. So here close a parenthesis and end with a semicolon. Now tell me what the function fopen returns. It returns a pointer to the beginning of this file, and that pointer value we copy into fp1. That means fp1 should be declared as what? Pointer to file. And when we say file star fp1, memory will be allocated. The name given to this memory location is fp1. So here I write fp1. Now tell me what will happen? fopen returns a null, and it should point to the beginning, and whatever it points to, that will be copied to which variable? fp1. So fp1 points to the beginning of the file now. So if I execute this file is opened in which mode? Read mode, and the function fopen returns a pointer to the beginning of this file, and that pointer will be copied into where now? fp1. So we are going to copy into fp1. Now we have to create how many files? 3 files. So first file I say out1.dat. I have to create a file, meaning I have to open this file in which mode? Write mode. So which function I have to open? fopen. Close a parenthesis, and it returns what? Now the moment if this statement is executed, a file if it is created, out1.dat, a file is successfully created. In that particular case, the function fopen returns a pointer, and that pointer value will be copied into where now? fpa. So here the moment we have, if I say fpa, memory will be allocated for fpa, and it should return pointer to this beginning of the function fopen. It is pointed to the beginning of this particular file. Okay. Now let us declare fpa. So here we say fpa is pointed to a file. And let us write another output file, output out2.dat. Again we have to create this file in which mode? W mode. So let me call the function fopen, and I will copy the whatever value the function fopen returns, I will copy into which variable? fp2. So if the operation is successful, is out2.dat, if it is created successfully, yes, if it is created successfully, what will happen? The pointer variable fp, whatever here the file is opened, it returns a pointer to the beginning of the file, and that will be copied into which variable? fpb. So into this FPB we copy the pointer to the beginning of the file. Now let us declare FPB as a pointer to a file. Now we have to read from FP1. So I write FP1. Maximum of how many characters we can read? 80 characters. In a line you can have maximum of 80 characters, but here we have what? Slash n. So it's not that you have to read all 80 characters. Till we encounter what? Slash n you can read. So read 80 characters, maximum 80 characters from where? FP1, and copy that into where? STR. Okay, so we require some memory to copy the data, so we write str of 80, which is of type character. So 80 bytes of memory will be allocated, and the name given to that name given to the first memory location is what here? STR. Now what will happen? We have to copy this one from FP1. From FP1 maximum how many characters? 80 characters. So from FP1 maximum 80. Here what we have? Only these many characters are there, and it should be copied into which variable? STR. So this can be achieved using the function fgetS. See, the data is read from the input file and it is copied to where now? STR. So apple is read from the memory, read from the file, and it is copied into STR. And the function fget returns a value, and that value will be copied to where now? PS. So we should declare PS. PS is a pointer. So PS now points to where now? STR. So let us declare PS as a pointer. Now tell me, PS points to the beginning of the string str, FP1 points to the beginning of the input file, FPA points to the end of the output one dot dat. FPB also points to the, it's not end, it is the beginning only. Now see what's happening here. Is apple is read from the memory, read from the file? Yes. Immediately after that, pointer points to the next one. So let us repeat this as long as it is not equal to null. So we write while. Is PS not equal to null? So PS definitely it is not equal to null. Control should enter into the body of the loop. So here we check if star PA, if it is equal to A. Now look here, PA points to the beginning of the string. What is the first? It is pointing to where now? A. Is PS is pointing to A? Yes, PS is pointing to A. If PS is pointing to A, then we send this str, whatever is there in whatever PS points to A apple, but to send A apple to where? FPA. This is FPA. FP is pointing to here. PS is pointing to this. So data is read from where PS is pointing to, and that should be written into where now? FPA. So this is read from the memory and it is copied here. Now immediately after the string is written into the file file pointer points to the next one. Again control goes back. Now if I execute this, tell me, if I execute this, what will happen? FP1 points where now? Amar. So Amar is read from the file and that will be copied where now? STR. Amar will be read from the file and that is copied into STR. But remember, pointer should be incremented automatically to the next one. Is PS is pointing to A? Yes, PS is pointing to A. So control comes here, and if we execute this, what will happen? This PS points to A means A Amar will be copied into FPA. So A Amar which will be copied into FP. FP is pointing to this. So and immediately after that, immediately after reading this, what will happen? Pointer points to the next one. Now if you observe, all characters starting from A will be written into which file? Input.dat. After writing into this, pointer points to the next one also. Now see what will happen. Let us execute this once again. If I execute this once again, tell me what will happen. B Baba will be copied into STR, and this pointer now points to the second one, second B. Now is PS is pointing to A? Definitely PS is not pointing to A. PS is pointing to B. So control comes to else part. Here we in the else part we check whether PS points to B. If PS points to B, let us print this in the second file. So what will happen when I say f put as PS FPB, this PS points to this, that is read from the memory and it will be sent where now FPB. So it will be sent to FPB here. After this it points to the next one. Similarly, control goes back. If control goes back, now tell me what will happen. This is read, this string is read, and it will be copied to where now str. So it is copied to str. Now control comes here. Tell me, is PS points to A? Is PS points to A? I'm sorry, this is PS points to A? No. So control comes here. Is PS points to B? Yes, PS points to B. Then whatever PS points to, that is B banana, should be copied into where now FPB. So B banana is copied into FPB, and this point will point to the next one. Now after executing this, again control goes back. Now tell me, if I execute this, where is pointer points to now? FP1 points to C cat. So that should be read and it will be copied to str. So C cat is read and that is copied to str. Now PS points where now? C. Is PS points to A? No. Now is PS points to no. Is PS points to A? No. So control comes here. Is PS points to B? No. So control should come to else part. In the else part, we say f put as PS comma standard output. So instead of creating one more file here, we are treating this monitor itself as the file pointer. So std out is a file pointer. That means whatever PS points to, we are sending to the monitor. So PS points to where now? PS points to C cat will be displayed onto the screen. On similar lines, C camel also will be displayed. Now finally what will happen? Nothing is there. We encounter end of the file. After reading C camel, we encounter end of the file. When we encounter end of the file, again PS will be what? Null. Is it null or not null? This condition will be failing. If this particular condition fails, what will happen? Control comes out. Once control comes out, let us close FP1, let us close FPA, and let us close FPB also. Okay, now all files pointers will be closed. Enclose all these statements within the braces, and here we write void main, and here we write hash include stdio.h. So this is the complete program. We are reading, we have an input file. All lines starting with lowercase letter a will be written into output one dot dat. All strings in the file which start from lowercase letter b will be written into the output file, and all the things which start from C will be written into the monitor, will be sent to the display unit such as the screen. Okay, now let us see what is the syntax of fgetC. fgetC, file pointer. For fgets there is only one argument, file pointer, where fp is pointer to a file from where a character has to be read. Next, let us declare fp. fp is a pointer to a file. The function fgets, this file is written, the file is defined where? It is defined in the stdio.h. So go here and write hash include stdio.h. So this is the syntax. If fp is pointing to a file, then a character is read from the file. After reading a character from the file, from the file pointer, this points to the next character automatically. Suppose this is the opened file. Immediately after reading this, automatically file pointer points to the next character. So this is very simple syntax. There is only one argument, fp. What it returns? An integer value corresponding to a character which is pointed to by fp. Next, EOF. If there is any error, EOF is returned, or when end of file is encountered. If there is any error or whenever we encounter end of file, the function fgets returns what? EOF. If there is any error, otherwise what it returns? An integer value corresponding to a character which is pointed to by fp, and that character will be copied into which variable now? ch. So ch we declare it as an integer. So this is the syntax of f get c. Now let us see what is the syntax of f put c. F put c, ch1, where ch1 is the character to be written into the file. This is the character to be written into the file. Here, so we declare ch1 as of type integer. Next, second argument is fp, where fp is a pointer to a file, to where the character has to be written. Using f get c, we read the character from the file, whereas using f put c, we write the character into the file. So let us declare fp. fp is pointing to where? File, where file is defined in stdio.h. So we include stdio.h. This is the syntax. If fp is pointing to a file, then a character is written into the file at the point of fp. After writing a character, the file pointer points to the next position automatically. So immediately after writing a character into the file pointer moves to the next character automatically. Now let us see what the function returns. An integer value corresponding to a character which is written into the file, EOF if there is any error. So whatever the function f put c returns, that let us copy that into variable ch2. So let us declare ch2 as of type integer. So this is the syntax of f put c. The returned value is stored in the variable ch2. So here the return value of this function f put c is stored in the variable ch2. Okay, now let us concentrate on some programs on how to copy a given file to another file. This is file copying. Let us see how to implement file copying. There is one input file by name say input.txt. Say it contains 5 characters vi, vek, vivek. Now let us display the message, enter the file onto the screen. Tell me, to get this message onto the screen, what is the statement I should write here? So I can write printf what? Enter the input file. Then I input this input.txt. So to enter this from the keyboard, what is the statement I should have? I can have scanf percentages of file1. So if you type input.txt and press enter, and that input.txt will be copied to which variable? File1. So file1 should be declared as an array of 10 characters. Enter the output file. So let me display the message. To display the message, enter the output file. Now tell me what is the statement I should write? Printf enter the output file. And here let me write output.txt. To get this, we have to enter this from the keyboard. So for that we have to write what? Scanf percentages file2. So what file2 now contains? Output.txt. So this text will be copied into which variable? File2. This input.txt will be copied into which variable? File1. So come here and define file2. Okay. Now let us, which is the first file? Input. This is the first file, input file. Let us try to open this particular file in read mode. So what we write? File1, comma r. We have to use which function? fopen, and it returns a pointer to the beginning of this file. And let us copy that into where now? Let us copy that into fp1. So here whatever value it returns, let us copy that into fp1. So fp1 should be declared as a pointer to a file. Now let us open the output file. Still output file has not been created. We have to create this output file. So for that we write file2. What is file2? Output.txt is your file2, and that is available in which variable? File2. So let us try to use that to open the file in which mode? Write mode. So I write a w. So these two arguments should be passed to the function fopen. Now the moment this statement is executed, what will happen is file2, what file2 contains? Output.txt. Output.txt is created, and it points to the beginning of the file. And that file pointer, let us call it as what? fp2. So I'll copy this into fp2. Now if you observe, there are two file pointers. input file pointer fp1 points to the beginning of the input file, fp2 which is the output file pointer, that will point to the beginning of the output file by name output.txt. Now how many files are opened? 2 files are opened. The first file is opened in which mode? Read mode. The second file is opened in which mode? Write mode. So let us declare fp2 as a pointer. Now we have to read a character by character from the input file and we have to send. So let me use the function fgetc fp1. Now whatever fp1 points were now v, that will be called, that is read. This v is read and that is copied into which variable? Ch. Now after that we check whether it is not equal to end of file. So this process has to be repeated, so we write while. Okay, now see what's happening here. fp1 points to where? V. That v is copied where now? Ch. That ch is compared with what? EOF. Now tell me, what is fp1? V. V is copied to where now? Ch. What ch now contains? V. That v and EOF we are comparing. Are they equal? No. So control comes into the while loop and let us send this character ch. What is there in ch? V to fp2. For that what had write? F put C. Now what ch contains? V. Ch contains V. We have to write that V into where now? fp2. So V comes here and at the same time let us declare the variable ch. Ch is of type what? Integer. Now what will happen? This V will come here. Next I will come here. Next V will come here. Next E comes here. Next K comes here. And the process will be repeated. I am sorry, this A is not there here. A is not there. The process is repeated. And what will happen? Finally, pointer comes here. This A is not there in the output file. And now tell me, file pointer, input file pointer points where now? End of file. And that end of file will be copied into which variable now? Ch. Now ch contains end of file. Is EOF not equal to EOF? It is not equal. If EOF not equal to EOF, it is equal. So what will happen? Control comes out of the while loop. And let us close fp1 and let us close fp2 also. Okay. So this A is not there in the output file. Please note it. All these statements must be enclosed within the braces and here we write void main and we include stdio.h. So this is the complete program to copy the contents of one file to another file. Okay, now let us concentrate on how to concatenate two input files and write into another file. So let us have one file by name input. How many files you should have? 2 input files you should have. Input 1.txt say contains Vivek and another file input 2.txt say contains Ananda. So how many files are there? 2 files, input 1.txt and input 2.txt. And we have to concatenate, we have to join these 2 files and we have to copy into another output file. So let us try to read input 1. We have to read these 2 files in which mode? Read mode. So I write R here and which function it invoke? fopen. And remember it points to where now? fp1. So we copy into fp1. Let us declare fp1 as pointed to where? File. Next we open this. So here I write input2.txt. In which mode? This also has to be opened in read mode. And which function we have to use? fopen. Now the function fopen returns a pointer to the beginning of this and we'll call this as what now? fp2. Okay, so the function fopen returns a pointer and that pointer value should be copied to where now? fp2. So here I write fp2. Now tell me, fp1 points to the beginning of the first input file, fp2 points to the beginning of the second file. So let us declare fp2. fp2 is a pointer. Now we have to create one output file. So if I want to create an output file, which mode I have to write here? W mode. So I write W. So which function I have to call now? fopen function I have to call. So now what will happen? The file output.txt is created and one pointer, it points to the beginning of this particular file and that we copy into where? fp3. So a pointer, let us copy into fp3. So declare fp3 as a pointer. Now tell me how to, you have to read from this file and you have to write into this. So get C from where? File pointer 1. Copy that into CH. Check whether CH is of type what? Integer. Check whether it is not equal to end of file and repeatedly execute this. So while. So here what to write? CH. You have to write into where? You have to write into FP3. So CH comma FP3. Which function to write now? F put C. So read each character from the file pointing to by FP1. Keep copying into where now? FP3. So first what will be coming here? V comes. Next. Now V has been returned. After that what will happen? I will come here. Next V will come here. E will come here, and finally K comes here. Automatically these pointers will be incremented. Now finally FP1 points to the end of the input file, and file pointer 3 points to the end of the output.txt. Now finally here what we have? End of file is there. That end of file is copied to where now? CH. If CH is not equal to end of file, it is equal to end of file. What will happen? Control comes out of the loop. Now here same thing we write here, but instead of copying from file pointer 1, we have to copy from file pointer 2. So what we write here? FP2, rest remains same. So here we write CH, if it is not equal to end of file, copy, that is CH into where now? FP3. So same statements have written here, but here we are copying from the first file, here we are copying from the second file. Now here if I repeatedly execute this, these characters will be copied one by one. So N will be copied, D will be copied, A will be copied. Now finally this pointer points to the end, this also points to the end. Now see, first FP1 points to end of the first file, FP2 points to end of the second file, FP3 points to end of the output file. Now let us close all the files. I'll close FP1, I'll close FP2, and I'll close FP3. Our job is over. All these statements we enclose within the braces. Here we write void main, and here we write hash include stdio.h. So this is the complete program which is used. Which is used to write? What is this program now? How to concatenate two input files and write into another file. Now the last program in our class is count number of characters, blanks, tabs and lines into a file. So we have input, say some characters vi /t/t 3/n followed by one space and v here. Let us open this file in which mode? Read mode. And this is your file pointer that will be copied into which variable? FP. Declare FP as a file. Now we have to open this file, and we have to start. File is opened successfully and it is pointing to this. Let us start reading from this. So here f get c of fp, copy that into ch, declare ch is an integer, and check whether it is not equal to uof. It has to be repeatedly executed, so we write while. Now what we should do? Character count, suppose it is equal to 0. Next blank count, it is equal to 0. Then line count equal to 0. Then finally TC, tab count, so it is also equal to 0. So what will happen? We allocate the memory for variable for character count 0, and then blank count is 0 0, line count is 0 0, tab count is 0 0, and this is your program. This is a complete program. You please go through this particular program. It is a very simple program and it is very straightforward. And here, as and when the character is incremented by 1, I am incrementing the character count by 1, and appropriately whether it is character count or blank count or tab count will be incremented by 1. And finally file pointer points to the end of the file, control comes out, we close the file pointers. Now if you display the message, we get the number of characters count, blank count, and finally we see the line count as well as a tab count equal to 2. So it is a very simple program. Go through this program and trace the program, and we get this output. And I think in this class we have completed file handling. In the previous classes I have explained the concept of structures, and in this chapter I explained how to do the file handling operations. So, I have completed module 4. Module 5 will be done in the next session.